Welcome to our lesson on the rules of differentiation. Differentiation is a fundamental concept in calculus that helps us find the rate at which a function changes. Today, we'll explore the 6 core rules of differentiation that will allow you to find the derivative of almost any function. These rules are the building blocks for more advanced calculus concepts, and mastering them will make solving complex problems much easier. Let's start with the power rule. The power rule states that if we have a function f of x equals x raised to the power n, where n is any real number, then the derivative of x to the power n equals n times x to the power n minus 1. The intuition behind this rule is that when you raise x to a power n, each time you increase x by a small amount, the rate of change grows roughly like n times x to 1 less power. Let's look at our first example. Find the derivative of f of x equals x to the 5th power. Using the power rule, we take the exponent 5 and multiply it in front, giving us 5. Then we reduce the exponent by 1, so 5 minus 1 is 4. So the derivative equals 5 times x to the 4th power. Let's try one more example. Find the derivative of g of x equals x to the 3/2 power. Using the power rule, we take the exponent 3/2 and multiply it in front. Then we reduce the exponent by 1, giving us 3/2 minus 1, which equals 1/2. So the derivative equals 3/2 times x to the 1/2 power, which we can rewrite as 3/2 times the square root of x. Next, let's look at the constant multiple rule. This rule states that the derivative of a constant c times a function h of x equals the constant c times the derivative of h of x. Let's see an example. Find the derivative of f of x equals 7 times x cubed. Using the constant multiple rule, we can pull the constant 7 outside the derivative. So the derivative equals 7 times the derivative of x cubed. Using the power rule for x cubed, the derivative is 3 times x squared. So our final answer is 7 times 3 times x squared, which equals 21x squared. Now let's explore the sum rule. The sum rule states that the derivative of a sum of functions equals the sum of their derivatives. Similarly, the derivative of a difference of functions equals the difference of their derivatives. Let's try an example. Find the derivative of f of x equals x to the 4th power plus 3 times x squared minus 5. Using the sum rule, we can differentiate each term separately. The derivative of x to the 4th power is 4 times x cubed. The derivative of 3 times x squared is 3 times 2 times x, which equals 6x. And the derivative of the constant 5 is 0, since constants have a derivative of 0. So our final answer is 4x cubed plus 6x. Let's move on to the product rule. The product rule states that if f of x equals u of x times v of x, then the derivative equals the derivative of u times v plus u times the derivative of v. This rule is a bit more complex. Intuitively, when we have a product of two functions, each one can change, and both changes affect the overall result. So we need to account for both the change in the first function while the second is fixed, and the change in the second function while the first is fixed. Let's look at an example. Find the derivative of f of x equals 2x times x cubed. Let's set u equals 2x and v equals x cubed. The derivative of u is 2. The derivative of v is 3 times x squared. Using the product rule, the derivative equals u prime times v plus u times v prime. So that's 2 times x cubed plus 2x times 3x squared. Simplifying, we get 2x cubed plus 6x cubed, which equals 8x cubed. Now, let's look at the quotient rule. The quotient rule states that if f of x equals u of x divided by v of x, then the derivative equals the derivative of u times v minus u times the derivative of v, all divided by v squared. This rule helps us find the derivative of one function divided by another. It can be remembered by the saying low d high minus high d low over low squared. Let's solve an example. Find the derivative of f of x equals x squared plus 1 divided by x. Let's set u equals x squared plus 1 and v equals x. The derivative of u is 2x. The derivative of v is 1. Using the quotient rule, the derivative equals u prime times v minus u times v prime, all divided by v squared. So that's 2x times x minus x squared plus 1 times 1, all divided by x squared. Simplifying, we get 2x squared minus x squared minus 1, all divided by x squared, which further simplifies to x squared minus 1, all divided by x squared. We can simplify this to 1 minus 1 over x squared. Finally, let's explore the chain rule. The chain rule states that if f of x equals h of g of x, which is a function of a function, then the derivative equals the derivative of the outer function h evaluated at g of x multiplied by the derivative of the inner function g of x. Intuitively, if we have a function inside another function, we need to account for how both functions change. The rate of change of the composite function is the product of the rate of change of the outer function with respect to the inner function and the rate of change of the inner function with respect to x. Let's look at an example. Find the derivative of f of x equals the quantity 3x squared plus 5 raised to the fourth power. We identify this as a composite function. The inner function g of x equals 3x squared plus 5, and the outer function h of u equals u to the fourth power. The derivative of the inner function g prime of x equals 6x. The derivative of the outer function h prime of u equals 4 times u cubed. Using the chain rule, the derivative equals h prime of g of x times g prime of x. So that's 4 times 3x squared plus 5, cubed times 6x. We can simplify this to 24x times 3x squared plus 5, cubed. Let's summarize the 6 key rules of differentiation we've covered today. 1. The power rule. The derivative of x to the n equals n times x to the n minus 1. 2. The constant multiple rule. The derivative of a constant times a function equals the constant times the derivative of the function. 3. The sum and difference rule. The derivative of a sum or difference of functions equals the sum or difference of their derivatives. 4. The product rule. The derivative of a product of functions equals the derivative of the first times the second, plus the first times the derivative of the second. 5. The quotient rule. For a fraction, the derivative equals the derivative of the numerator times the denominator, minus the numerator times the derivative of the denominator, all divided by the denominator squared. 6. The chain rule. For a composite function, the derivative equals the derivative of the outer function evaluated at the inner function times the derivative of the inner function. With these 6 rules, you can differentiate nearly any function you'll encounter in basic calculus. Remember to identify the structure of your function first, then apply the appropriate rule or combination of rules step by step.